Hello everyone, my name is Sajid and I'm group 20, unfortunately only one member, and I'm going to present client's classification of fire extinguisher inspection, but using PSO and GA formula. So what's the engineering problem for classification of fire extinguishers to be pass or fail? Fire extinguishers, as you can see in the small videos here, the first video shows that it is just recognizing it, classifying it as a bottle. That's not actually my project, but I want to show you that after the data set that I got from RoboFlow, and on the right side, after classifying it with more than 571 images, I got the classification running correctly, and it tells us the exact data as you can see on the right in the right video. So what I use here is YOLO, which is you only look or live once. So YOLO is an AI tool that detects the defects in the object. So for here I use fire extinguisher to detect the parts or components of a fire extinguisher here, right? But YOLO detects 7 components for me here, but that's not the real case. The thing is, it still cannot be sure for an inspector to say that this fire extinguisher or fire equipment is pass or fail. So when an inspector goes for an inspection in a building, so he can detect the fire extinguisher, but it cannot tell you exactly if it is working or not. It can only detect the parts of it here. So to be sure if it is pass or fail, I use PSO and GA to find the best classified settings for this. So I use 2-layer system. The first one I already told you about the YOLO. That's the first layer, but the second layer that I use is GA and PSO, and that classifies has for that the classified has 5 settings that controls how it makes decisions. So after the detection, human must be involved in this process, and he can say in the end that it is pass or it is fail. But what exactly is helping the inspector is algorithm. So I use 5 settings that control how it makes decisions. As you can see, X1 to X5. X1 is confidence threshold, which is minimum Euro score is the threat, and X2 is class rates, X3 is network depth, X4 is feature mask, which will be used in future as well, and regularization X5. Before moving forward, I just want to let you know how it works exactly. You see on the first row of XR10 camera, I use XR10 camera for the live feed, and then a YOLO detection for the 7 confidence scores, and then classify this project, and then at the end I will get the result as a pass or fail. Then I will be saying that yeah, this extinguisher equipment will be working in the building and it's safe. So algorithm design, second part. So PSO and GA. So both algorithms search for the best combination of X1 to X5, as I already mentioned, and they run for the same number of evaluations so that the comparison is fair. And PSO has 30 candidate solutions that move around to search for the space spontaneously, and then each one remembers its own best position, and that SMOPS shares the global best as well. So G best. And GA has the 30 candidate solutions act as a population. The best one breed together, crossover, and occasionally mutate. Each generation is better than the last until the best configuration is found. So I will show you, you may find it complicated here, but I will show you the diagram and you will get the idea how it exactly works. So for that I use PSO 30 particles and GA 30 chromosomes as a population size. Algorithm differentiation, what makes this work different? The 3 important specific ways that are adapted for PSO and GA. The first one, as you can see, feature selection is the part of the search. Second is the mixed chromosome for GA, and the third one is real-time deployment constraints. This is the component map, as you can see on the right side of your screen. This is how I map the design, but before going forward with the coding, I used this Augustian graph to draw the algorithm component map for it. So as you can see on the right side, the X4 is the most connected variables with different colors, and a sequence conflict was also found, PSO velocity, and for the X4, and the design was completed before the coding. So before going forward with for the coding, the design was completely built with the help of Augustian graph map for the component map, as you can see on the right side of your screen. Next is the data set. So where did I get all the data set that I used to train the Euro and to get the confidence score for GA and PSO? So we already had some of the examples in the presentation instructions by the professor, but I used RoboFlow. I didn't use Kaggle. Kaggle is also one of the important tool to get the data set for the tools to detect, but I found it a bit complicated. So I used RoboFlow. It was easy, and I downloaded all the data set and all the images for the detection. And total of the images that I downloaded was 571, and some of the images that I used for it, I also captured in my own phone, more about 100 to 200. And then around 491 I tried for the training and testing, and 80 of them for testing. And you can see the 7 classes were detected with the help of Euro V8, so that's the layer 1. And 7 components were classified. And the 7 components classes were, as you can see on the left side, pin seal, pressure gauge, shell, hose, nose, and service tag and safety pin. Safety pin is the least trained model here. Why? Because it has only 19.8%. So when I was running this in Python, so it gave me the result for safety pin the lowest. So it's
1 minute.
Sure.
Please finish in 1 minute.
Okay, sure. So this is the data set that I went for. So I will be quick from here. This is the, okay, I will show you a quick live demo here. Please allow me. Okay. So here is the PSO and GA optimization. So I will simply go quickly for the run optimization. As you can see, it runs iteration best accuracy, and you will find the result in the box at the bottom, optimization solution found, which is X1 to X5. You can see the threshold 0.65, hidden layers, safety pin, and also the regularization. So the total accuracy, cross validation accuracy was 88.1. And if I go for GA, also it goes for 30 candidates at the same time, it finds the best solution. And for the live demo, if I will press any of the, if I use any of the component from here, if I go decrease here, you see it fails the baseline. And if I go for other components for spin seal, you will see the difference on the right side of your screen at the same time, right? And for the results, you can see at the end here, I will also show you the presentation. So optimization results, baseline, as you can see, as I already showed you, 82.4%, and logistic regression, 84.9, optimization for PSO, 88.1, which is one of the important part of this project, and GA optimization, 87.8 for the accuracy. Oh, I already showed this one, so I will skip this one, and also this one also I showed you the features. So I will go directly to conclusions here because of the time limit. So what was achieved in the project? So what we have achieved, classifier now translates 7 Euro CDs at the same time in a single pass or fail verdict to manual interpretation. And 5.7 accuracy was more improvement found in the layer 2, and the safety finish was excluded because the percentage of confidence was only 19.7% something, not more than 80%. And now it's ready for deployment, and we can use it for the inspection. Thank you so much.